Hello and welcome back to Introduction to Number Theory. As you might remember, we have already calculated the value of the continued fraction written here on the board. But I don't know about you, but it was a bit painful to me because all these calculations, fractions, enormous fractions and everything. So I would like to show you an alternative method for calculating values of continued fractions. Let's first consider the general situation and put Pn over Qn to be equal to A0, A1, A2, and so on, an minus 1. An, well, simply a finite continued fraction, and convergent, which is equal to this continued fraction. And the neighbor convergent, neighbor continued fraction, Pn minus 1 over Qn minus 1, which differs from this only by excluding an. So it's equal to A0, A1, A2, and so on, an minus 1. It appears that only using Pn minus 1 and Qn minus 1 and an, we can find this fraction. Well, if we unite all these three, we can calculate this fraction over here, which of course means that Pn minus 1 over Qn minus 1 contains all of the information about this part of the continued fraction, and all that is added is an. Formulas that give us this connection are indeed not so complicated. Pn is equal to an multiplied by Pn minus 1 plus Pn minus 2. And Qn is equal to an multiplied by Qn minus 1 plus Qn minus 2. So, as you can see, I was actually wrong. I fooled you just a bit, because we need not only the previous continuous fraction, but the one before the previous. So we need two previous p's and two previous q's. But since we can take our initial continued fraction and just start from the beginning, we will have all these previous numerators and denominators of convergence. So why is it true? How to prove this? It's actually really simple. All we need to do is to remember that P is continuant. Well, P with some index is the continuant, also with some index, of some variables. Of course, I can write very detailed these indices and these variables, and then very detailed prove everything. But I want to give you just a sense of the idea. Well, we know that the continuant is equal to, the continuant satisfies a recurrent equation. Well, this continuant is equal to its first variable multiplied by previous continuant and plus the one before previous. And I will not write any more formula. We have here all that we need, because, well, we know that x in the recurrent equation that we know from before, we know that x is the first variable here. But the continuants are symmetric. If we take all the variables inside the continuant and turn them around, well, this way, exchange places, then the continuant will not change. And using this property, we can prove this recurrent equation where x is the last variable in the continuant. And then, using this and knowing that p and also q are equal to continuants of some variables, we can prove these two equalities. Now let's check whether this really helps find the value of a continued fraction. We need to start from p0 and q0. Well, p0 is equal to 1, and q0 is also equal to 1. However, in order to calculate p2 and q2, we need to know not only to calculate p1 and q1, we need to know not only p0 and q0, but also p minus 1 and q minus 1. Well, what could that be? It turns out that for any continued fraction, you can put p minus 1 equal to 1 and q with index minus 1 equal to 0. Please not be upset knowing that q is the denominator and it's like we have 0 in the denominator. Well, we will not consider fractions p minus 1 over q minus 1. Well, we will not at least try to calculate them. And this 1 will be equal to 1 for any continued fraction. This number 1 here is because our continued fractions start with number 1. And this will always be number 1. So this is a general rule. And now, using our fraction continued and using p's and q's, we can calculate all the other. Well, let's try. So, according to the formula, p1 is equal to 1 multiplied by 24 plus 1, which gives us 25. Q1 is equal to, well, 1 multiplied by 24 plus 0, which gives us 24. Well, okay. So, P2 is equal to P1 multiplied by 2, which is 50, and plus 1, 51. Q2 is equal to Q1 multiplied by 2 and plus Q0, which gives us 49. The next one, P3 is equal to 51 multiplied by 1. Well, this is A1, A2, A3. So, yes, that's right. 51 multiplied by 1, which is 51, plus the previous one, which gives us 76. Q3 is equal to 49 multiplied by 1 plus 24, which is equal to 73. We have 3 more left, and I don't think I need to continue. This is much more pleasant than folding the enormous continued fraction. So I surely recommend you use this formula. And finally, I would like to ask you to really make sure that this ends with p at some step, p equal to 1777 and q equal to 1707. By the way, why on earth have I chosen these numbers? The question is still open.